Hello, and welcome to this video in which I am going to demonstrate some problem-solving strategies using the LeapYear lab kind of as our basis for how we're going to get through this. So this problem-solving strategy I'm going to demonstrate here for you is the idea that you first break down the idea of what you're going to do in this lab into pseudocode. And I'm going to develop that through stages. I'm going to think about, what this lab entail at its most basic level, and then build into it some additional tasks, right? We develop it to be able to handle additional criteria, to do new things, or to handle special cases. But first, let's think through what it does in the beginning. So you can see here I have declared my class, got my main method. I've imported my java.utility so that I can create a scanner. Creating that scanner allows me to take an input. So I prompt the user to enter a year. I declare and initialize a variable to represent that year, and I use that scanner to capture the data from the user. Okay, basic stuff. So now let's talk about the logic of our program, what we want LeapYear to do essentially. And the basics is that it checks a year, checks whether or not a year is a leap year or not a leap year. And so what type of structure allows us to evaluate some criteria and then decide which type of code to run based on that criteria? That should be an if-else structure. So we can start off, basic program will decide if leap year or not. All right, so that's our basic program. We do that with an if, and then we can build our criteria. Is leap year. Now this is just going to fit in here so that I can kind of show you the structure. Obviously, this criteria needs to evaluate as true or false, right? Is leap year true? If it is, then what are we going to do? Well, essentially, we are going to say it is a leap year. And if it's not a leap year, we want to do something different. So I build that else. And inside of that else, what am I going to do? I am going to say it is not a leap year. So this is our basic structure. Either it's a leap year or it's not a leap year. And you can see here this decision tree. If this is true, this is what I do. Else, this is what I'm going to do. So that's stage one. If you can get this operating so that things that are leap years say leap year, years that are not leap years say that it's not a leap year, you have completed stage one. Now, stage two is about developing this else statement. So I'm going to work exclusively inside of here. And basically, after I say it's not a leap year, then I need to kind of condition what it does, because I want to know stage two is used to decide the closest leap year. Since it's not a leap year, I need to figure out what is the closest leap year. And now there are going to be four possibilities. And those four possibilities is either it is off by 1 year, it's off by 2 years, it's off by 3 years, or it's off by 4 years because it's a special case. So those four possibilities, I need to be able to code for those four different possibilities. So we'll say if off by 1 year, what needs to happen? So I'm just going to build the structure first. Once we check if it's off by 1 year, then we can do an else if off by 2 years, and we'll tell it what to do if that's the situation. else if off by 3 years, well then that would be our code we'll do for that. And finally, the last scenario is off by 4 years, but I don't need to condition that, because those are the only possibilities. It recycles after that. So I can just end this with an else. And this is my basic structure here. Once I decide it's not a leap year, I need to build 4 possibilities: off by 1 year, off by 2 years, off by 3 years, or off by 4 years. So that is stage 2. And we can just kind of build this as though we don't have any special cases. So if it's off by 1 year, what do I want to do? I want to subtract 1. So off by 1 year, that means it's more than. So say, take for example 1988 is a leap year. So 1989 is over by 1 year. And so we could actually change this to over by 1 year, and over by 2 years, and we could do over by 3 years, and then over by 4 years. All right, that makes it a little clearer what we're doing here. So subtract 1, and then if it's over by 2, this is where we want to, we'll come back to this actually in a second. Over by 3 years, then we're just going to add 1 to the year. All right. If it's off by 4 years or off by 2 years, that's where we have a possibility. We can go higher or we can go lower. But if it's off over by 1 or over by 3, the closest one is always kind of right there. We know what to do. So over by 2, well, it's possible that I could add 2 or subtract 2. So I'm going to set that up by doing a coin flip. So I'm going to flip a coin, not literally, but the equivalent of that in a code. So the coin flip, and if the code is makes it less than, so if option A, what do I want to do? I want to add 2. Let me get a comment. Let's add 2. If that coin flip did not result in option A, then I will code it to do something different, such as, let's say, subtract 2. Now I have it randomized. The coin flip is a random action, and I need to write the code so that it's a 50-50 chance that it's either going to add 2 or subtract 2. We've done this in notes. You should be able to kind of figure that out. I'm just going to copy this because really off by 4 years is the same thing. It's just I'm going to add 4 or subtract 4. Now these are those special cases, right? This would be a special case where it's not a leap year because divides by 100, but not 400. All right, so what example would that be? 1900 or 2100. Those are the most recent examples of situations where I would have to go either up for 1904, down for 1896, etc. Okay, so that's stage 2. And again, what we've done here is we've built the basic logic. All right, so we have an if-else structure. Inside of this else, we've divided it into 4 possibilities: over by 1, over by 2, over by 3, otherwise over by 4, which is a special case. So that we've built it now so it handles 99% of the situations that we want it to handle. But there's those rare occasions, such as 1901. 1901 is over by 1, yet subtracting 1 from 1901 gets me to 1900. 1900 is not a leap year. So under this condition, I'm not always going to subtract 1. I'm only going to subtract 1, right? And here is my stage 3. So stage 3 is to condition for special cases. And so we're going to look at each of these conditions, each of these 4 possibilities, and build into a condition here. So if, we can do this with an if, subtracting 1, and so we'll put in a line comment here. So we'll do it this way so that it will be able to CSD for me. So subtracting 1 makes a leap year. And then we'll end that comment and we'll put a true here so that we'll still be able to generate CSD. So if that is true, then we are going to subtract 1. Else, meaning that the case of 1901, subtracting 1 gives me 1900. 1900 is not a leap year, so this would be false. So 1901 needs to go up to 1904. So that would mean I would need to add 3. So under that situation, I've now conditioned over by 1. If it's a normal year, I subtract 1. But if not, if subtracting 1 does not make a leap year, then I add 3. And we can basically do the same thing down here. We'll just copy that. And down here for our 3 years, we'll just kind of throw that in there. So instead of subtracting 1, if adding 1 makes a leap year, then I'm going to add 1. Otherwise, I'm going to subtract 1, or subtract 3. So now I've got that built to take care of 2001 and 2099, 1899, those kind of years. It works for there. So now, what about this over by 2 years? Well, I think it's probably a little easier here. I could go in here and condition each of these, but I think it's probably a little easier to kind of think about this as to check for whether or not it's going to make a special case. So if, and we'll throw this in here, adding 2 makes a special case. So now notice I am not looking for a leap year. I'm looking for a special case. So if that is true, that adding 2 makes a special case, well then I'm going to subtract 2. Do the opposite of what would make the special case. Adding 2 makes a special case, so I subtract 2. And now let's check for another one. So we're just going to copy this, throw that right there on the end. Instead of adding 2, subtracting 2 makes a special case, then I'm going to add 2. And now, if neither one of these happen, if adding 2 doesn't make a special case and subtracting 2 doesn't make a special case, well then I'm going to do a coin flip. So I'm just going to make this an else if. So do my coin flip. Else if coin flip, option A. So this is really built into this. So we'll build that so that you see the coin flip is actually happening, should be happening inside of that if statement there. So if adding 2 makes a special case, subtract. If subtracting 2 makes a special case, add 2. Otherwise, do a coin flip and pick between adding or subtracting. Doesn't matter which one happens because I've checked for both of them making special cases. And down here, off by 4 years, really doesn't matter because if 1900, if it gets down here to 1900, that's already a special case. The only way to get here are years like that. And adding 4 or subtracting 4 doesn't matter because there's not going to be another special case that close to it. So that's it. That's the logic of the program. And hopefully you kind of see what I was talking about in terms of building the simple structure. I built this if else first, and then inside the else, I built my stage 2. Inside of that, I conditioned each of these to do different things depending on if it was a special case or not. So that's the basic breakdown of how you can do this lab, not by jumping into the code right away, but by breaking the problem down into its simplest essence of what it's trying to do and developing it in stages to do more sophisticated tasks once you have that base satisfied. That is a problem-solving strategy. I hope this makes this lab a little easier for you and helps you to understand how to solve these better.